Hey everyone, today we're going to discuss about the regular payments of a simple annuity. In our previous lessons, we've learned how to solve for the future value and the present value of simple ordinary annuity and simple annuity due. Now, for today's discussion, we will learn how to determine the regular payments given the future value and the present value. So, for the regular payment of a simple ordinary annuity, we have the periodic payment is equal to future value times the interest divided by 1 plus I raised to n minus 1. And if the present value is given, we have P is equal to present value times I all over 1 minus the quantity 1 plus I raised to negative n. We'll be using the same variables as we've used in our previous video. So the I would represent the interest rate per period and n represents the total number of conversion periods. In the regular payments of a simple annuity due, it is similar with the previous formulas. It's just that we're just going to add 1 plus I on the denominator. So, the regular payments by a simple annuity due is represented as P, the periodic payments, is equal to future value times I all over the quantity 1 plus I raised to n minus 1 multiplied to 1 plus I. And if the present value is given, it is P is equal to present value times I all over the quantity 1 minus the quantity 1 plus I raised to negative n and multiply that with 1 plus I. As you can see there, the formula for simple ordinary annuity and simple annuity due are almost similar. It's just that we just add a factor of 1 plus I in the denominator to get the simple annuity due. So, let's have an example. How much should you deposit at the end of each month on an account that earns 1.2% interest compounded monthly if you want to have 50,000 at the end of 1 year? So let's analyze what we're given here. So we would like to know how much are we going to deposit at the end of each month. So since it's an end of each month, we're going to use the simple ordinary annuity formulas. And the interest is I is equal to 1.2. And take note that it is compounded monthly. So 1.2% is divided by 12. And it is equal to 0.1% or simply 0.01. It's converted as a decimal. Now for the number of compoundments, we have a 1 year multiplied by 12 compoundments or 12 compounding periods in 1 year. So the n is equal to 12. And take note that we'd like the value of the money in the future after 1 year is 50,000. So that represents our future value, which is equal to 50,000. So let's use this given here in our formula. So I is 0.001, n is 12, and future value is 50,000. So the periodic payments is equal to future value times the interest all over 1 plus I raised to n minus 1. So the periodic payment is equal to 50,000 times 0.001, that is our interest, all over 1 plus 0.001 would be equal to 1.001. I added 1 immediately, and n is 12 minus 1. So let's use our calculator to compute for the periodic payment. I would recommend doing this one first and doing this. Then we multiply by 50,000. Or we can just multiply 50,000 to 0.001 immediately, then do the denominator, then divide them. Using the calculator to compute for this, we should be able to get the periodic payment is equal to 4143.0 799,628, or simply 80. So the periodic payments that you're supposed to do to get 50,000 at the end of 1 year is 4,143 pesos and 80 centavos. So that's how we compute for the regular payments of a future value or present value of either ordinary annuity and annuity due. So I hope you guys learned a lot today. Thank you guys for watching, and see you guys on the next video.